This is properties of parallelograms practice. This we did in class and got in class on December 11th, so Tuesday, December 11th. So we broke it up into kind of sections. So 1 through 4, we're going to use the property of parallelograms that says consecutive angles are supplementary. So in parallelograms, consecutive angles, I said sides. Consecutive angles are supplementary. So we have to make sure we understand the vocabulary here. So parallelograms are quadrilaterals with two opposite sides, two pairs of sides that are congruent. So two pairs of opposite sides that are congruent. That are parallel. Okay. So parallelograms are quadrilaterals, meaning they are four-sided figures that have two pairs of parallel sides. Parallelogram, so parallel sides. So a parallelogram is a quadrilateral with two pairs of parallel sides. Consecutive angles. So we can either have consecutive angles or angles that are right next to each other. So if we have A, B, C, and D, A and B are consecutive angles. Angle A and angle B are consecutive because they're right next to each other. Angle A and D are consecutive because they're right next to each other. Angle C and angle D are consecutive because they're right next to each other. And then angle B and angle C are consecutive. The opposite one is, the other one is opposite. So angle A and angle C are opposite angles. Okay, and angle B and angle D are opposite angles. Okay, we know, or we'll see later on, that opposite angles are congruent. But here with this one, we're sticking with consecutive angles. So on your reference sheet, under parallelograms, the first property says that they have two pairs of opposite sides that are parallel. That's how we're defining parallelograms. Having two pairs of opposite sides that are parallel defines the parallelogram. Okay, and then you have four additional properties. One of those additional properties is that consecutive angles are supplementary. So consecutive angles are angles that are right next to each other. Supplementary means the angle measures add up to 180 degrees. So here we have consecutive angles. And since it's a parallelogram, it's telling us it's a parallelogram. We know those consecutive angles are supplementary, so we know those angles add up to 180 degrees. So x plus 51 is going to equal 180 degrees. Minus 51 from both sides, subtract 51 from both sides, and the value of x is going to be 129. Okay. Number 2, again, we have consecutive angles. We know consecutive angles are supplementary, so x plus 76 is going to be 180. Minus 76, x is going to be 104. These two angles are next to each other. They're consecutive angles. So we know they're going to be supplementary. Minus 154 from both sides. Subtract 154 from both sides. X is going to be 26. Okay. And the last one here, again, we have consecutive sides that are right next to each other. So we have x plus 82 is going to be 180. Okay, minus 82, subtract 82 from both sides, x is going to be 98. Okay, and again, why are the consecutive angles supplementary? Well, we know a parallelogram is defined as having two pairs of opposite sides that are parallel. So we know these two lines are parallel. So we know these two angles are same side interior angles. And we know that by the same side interior angle theorem that if the lines are parallel, which they are, then the same side interior angles are supplementary. So we know these two angles are supplementary, so they add up to 180. So in a parallelogram, consecutive angles are supplementary. Next one, so 5 through 8, we're going to use a different property. So again, on your reference sheet, we have 5 properties listed. The first property says that a parallelogram has 2 pairs of opposite sides that are parallel. That's the property that defines the parallelogram. A parallelogram is defined as having 2 pairs of opposite sides that are parallel. Okay, then we have consecutive angles are supplementary. And then here, for these, we're going to use the property that opposite sides are congruent. Opposite sides are congruent. So first, let's label our diagram. So DG is 2x plus 2. EF is 3x minus 3. Okay, DE is 3x plus 1. And GF is 2x plus 6. Okay, again, our property says that opposite sides are congruent. So let's pick a side. So let's just pick DE. Okay. What's going to be congruent to DE? Well, the side that's opposite DE is GF. So DE and GF are congruent. Okay, so therefore the length of DE is going to equal the length of GF. So 3x plus 1 is going to equal 2x plus 6. Subtract 2x from both sides. We get x plus 1 equals 6. Subtract 1 from both sides, and x is going to be 5. The other way we could have done it is we could have said that DG was congruent to EF. Okay, so DG is congruent to EF, so 2x plus 2 is going to equal 3x minus 3. So here, minus 2x, subtract 2x from both sides. We have x minus 3. Add 3 to both sides. 5 equals x. So either way, we know x is going to be 5. So you don't have to do it both ways. Just pick one way. That should get you to the right answer. If you substitute it back in, right, these two sides should be the same. So 2 times 5 is 10. 10 plus 6 is 16. Okay, 3 times 5 is 15. 15 plus 1 is 16. And then we have 2 times 5 is 10, plus 2 is 12. 3 times 5 is 15. 15 minus 3 is 12. So here we see opposite sides of the parallelogram are going to be the same length. Number 5, same thing, except we're going to find A this time. So I'm not going to do it out both ways. I'm just going to do it one way. We'll pick one equation and find the answer. So DG is 4A. EF is 5A minus 6. DE is 3A plus 2. And then GF is 2A plus 8. So we just had to pick 2 opposite sides. This one looks simplest. So let's go with DG. So DG is congruent to EF. DE is also congruent to GF, but let's stick with DG. So 4A is going to equal 5A minus 6 because they are opposite sides. And opposite sides are congruent, so therefore their lengths are going to be equal. Minus 5A, subtract 5A. We get negative A equals negative 6. Divide both sides by negative 1, and we're going to come up with A equals 6. If we want to double check our answer, we can substitute it in, see if we did it right. So 4 times 6 is 24. 5 times 6 is 30. 30 minus 6 is 24. 2 times 6 is 12. 12 plus 8 is 20. Okay. 3 times 6 is 18. 18 plus 2 is 20. So we see opposite sides are the same. Okay, 20 and 20 and 24 and 24. Opposite sides are congruent, so they have the same lengths. Number 6. So now on to number 7. DG is 2R plus 3. EF is 3R minus 3. DE is 2R plus 6, and GF is 4R minus 6. Again, we can pick either pair of opposite sides, doesn't matter. 2R plus 3 is going to equal 3R minus 3. Right, so DG is congruent to EF. Minus 2R. Subtract 2R from both sides. 3 is going to be R minus 3. Add 3 to both sides. Okay, 6 is equal to R. Substitute in just to make sure we're right. So 4 times 6 is 24. 24 minus 6 is 18. 2 times 6 is 12. 12 plus 6 is 18. 3 times 6 is 18. 18 minus 3 is 15. 2 times 6 is 12. 12 plus 3 is 15. So again, our opposite sides are congruent. Our opposite sides are the same length. So that's number 7 is R equals 6. Number 19, or number 8, I don't know where we got 19 from. Number 8, DG is 2t minus 10. EF is t plus 5. DE is t plus 15. And GF is 2t. So I'm just going to pick, again, I like the 2t because it only has, it's simpler. We don't have the two parts. So GF is congruent to DE because they're opposite sides. It's a parallelogram, and in parallelograms, opposite sides are congruent. So if the opposite sides are congruent, then their lengths are going to be equal. So the length of GF is 2t. The length of DE is t plus 15. If we subtract t from both sides, we're going to get t equals 15. 2 times 15 is 30. 15 plus 15 is 30. Okay. 15 plus 5 is 20. 2 times 15 is 30. 30 minus 10 is 20. So we have 30 and 30, 20 and 20. So we know we are correct. And again, if we had done the other one, we would have gotten the same thing, right? If we had done 2t minus 10 equals t plus 5, we could have subtracted t from both sides and got t minus 10 equals 5. Add 10 to both sides, t is going to be 15. So either way, we get t equals 15. So far, we know a parallelogram is defined as having two pairs of parallel sides. It's a quadrilateral that has two pairs of parallel sides. The opposite sides are parallel. Okay, and two properties we talked about so far are that consecutive angles are supplementary. So two angles that are next to each other are going to add up to 180 degrees. So angle G and angle F, the measure of angle G plus the measure of angle F would equal 180 degrees. And we know that the opposite sides are congruent. So GF is going to be congruent to DE, and GD is congruent to EF. Since the sides are congruent, their lengths are going to be the same. So GF is going to be equal to DE, and GD is going to be equal to EF. Let's go down to 9 and 10. So we're going to use those two properties for these two problems. So find the value of B in each parallelogram, then find each side length or angle measure. So we know parallelograms have opposite sides that are congruent. So since these sides are congruent, they're opposite sides, therefore they're congruent. Since they're congruent, their lengths are going to be equal to each other. So B plus 14.5 is going to equal 20.5. The opposite sides are going to equal each other. Subtract 14.5. B is going to equal 6. 5.5 plus half is 6. Okay. What's the question asking for? It wants us to find each side length or angle measure. So 14.5 plus, so this is going to be 6 plus 14.5, which should be 20.5, which is the same as this one down here, 20.5, because opposite sides are going to be equal. This one then, 3 times b, so 3 times 6 minus 6.3. That's going to be 18 minus 6.3, which is going to give us 11.7. Okay, so this side is 11.7, which means this side is also 11.7. 20.5, 20.5, 11.7, and 11.7. Okay, number 10. Find the value of S. So this one's S, not B. Okay, are these angles consecutive angles or opposite angles? They are consecutive angles because they are right next to each other. And we know consecutive angles are supplementary. So the measure of the two angles that are right next to each other is going to add up to 180 degrees. So the measure of this angle is 8S plus 5 plus 3S plus 10. So these two angles are next to each other, so they're consecutive. And we know in a parallelogram, right, and this is given to us that it's a parallelogram. So in a parallelogram, consecutive sides, right, the sides that are right next to each other, are going to add up to 180. They're going to be supplementary, so they're going to add up to 180. Combine like terms, we're going to have 11S plus 15 equals 180. Subtract 15 from both sides. We have 11S equals 165. Uh, 11S goes into 165. What do we have? 9 and 6, 15 times. So S is going to be 15. My S's and 5s look like each other. This is an S. That's a 5. This is an S. That's a 5. This is an S. That's a 5. S. S is going to be 15. Again, it wants us to find each side length or angle measures. So here we're going to find the angle measures. Okay. So this one's going to be 8 times 15 plus 5. Okay, 8 times 15 is like 30 times 4. 30 times 4 is going to be 120. Which is going to give us 125 degrees. 3 times 15 plus 10 can give us 45 plus 10 is going to give us 55. Again, these two angles had better add up to 180 because we know consecutive angles are supplementary. Okay, we got to find our other angle measures. So again, we can either do, these are consecutive, so 180 minus 55, which is going to give us 125, or we can know that opposite angles are congruent. So this one is going to be 125. This one is going to be 55. Opposite angles are congruent, or we can do consecutive again, right? These are consecutive angles. So 180 minus 55 gives us 125. 180 minus 125 gives us 55. Then these are consecutive, so they have to add up to 180 as well. So 55 plus 125 is 180. So that's 10, 9, and 10. 11 is asking for the special types of parallelograms. It's just trying to foreshadow what we're going to be doing tomorrow with the special parallelograms. So this again is all on your reference sheet. Okay, draw the 3 special types of parallelograms. So we know a parallelogram is defined as having 2 pairs of parallel sides. Okay. This one has our 3 special types. So our special types are rhombuses. Okay. Rhombuses are parallelograms that have 4 congruent sides. And then we have rectangles. Rectangles are defined as parallelograms that have 4 right angles. Okay, so this is a rhombus. This is a rectangle. So rhombuses are parallelograms, right? And a parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay. 2 pairs of parallel sides, so it's a parallelogram. Okay, but it's a parallelogram that has 4 congruent, 4 congruent sides. Okay, and a rectangle is a parallel. Again, it's a parallelogram, 2 pairs of parallel sides. Okay, but it's defined as a parallelogram that has 4 right angles. If we combine these together, okay, we are going to get a square. So a square is both a rectangle and a rhombus. A square is going to be defined as having 4 congruent sides and 4 right angles. So a square has 4 congruent sides and 4 right angles. So this is what we're going to talk about next, but these objects are all parallelograms because they have 2 pairs of parallel sides, and a parallelogram is defined as a quadrilateral that has 2 pairs of parallel sides. So these are all 4-sided figures that have 2 pairs of parallel sides. Okay, a rhombus is defined as a parallelogram that has 4 congruent sides. A rectangle is defined as a parallelogram that has 4 right angles. A square is a parallelogram that has both 4 congruent sides and 4 right angles. So a square has both 4 congruent sides and 4 right angles. It's defined as having both. It's both a rectangle and a rhombus. This is 6.2. So number 12. So we've gone through 2 of the properties of parallelograms. They shouldn't have asked that at that point. That should have been like at the end, but that's fine. That's fine. We'll answer it whenever we get it. So our third property here is going to be that diagonals bisect each other. So in parallelograms, diagonals bisect each other. Okay. How long are we at so far? 23 minutes. First thing is we have to know what diagonals are. So we name our parallelogram A, B, C, D. Okay. Our diagonals are going to be AC and B, right below. AC and BD. So AC and BD. Those are our diagonals. So it says in parallelograms, diagonals bisect each other. So the other word we have to know there besides diagonals, we have to know what diagonals are. We also need to know what a bisector is. So a bisector, we can either have a segment bisector or an angle bisector. Okay, but either way, it's going to split it in half. So if we have a segment bisector, we're going to split the segment into 2 congruent pieces. So we're going to split it in half into 2 congruent pieces. Okay, so if I have a line, we'll call it BD. Okay. And I have a bisector. I'm going to have a line AC that bisects BD. So AC is going to bisect BD. That means it splits it in half. So it splits it into 2 congruent pieces. We call this point E. Right? We would say that BE is congruent to ED. So for our purposes, we're saying that they bisect each other. So we're also saying that BD is going to bisect AC. Okay, so if we're bisecting AC, we're splitting AC in half. We're splitting into two congruent segments. So we're going to split AC. BD is the line BD is going to split AC into two congruent segments. So EC is going to be congruent to AE. Right? And note that BE is not congruent to AE. BE is congruent to ED. These two pieces are congruent. And then AE is congruent to EC. Right? But BE is not congruent to AE. BE is not congruent to EC. Okay, it's only going to be congruent to ED. Right, so if you look at our triangle, I'm going to put an E in the middle. I think it's easier to understand if we have an E so we can name our segments. We know AE, okay, is going to be congruent to EC. Okay? So diagonal BD bisects AC. They bisect each other. So BD bisects AC, meaning it splits it in half. It splits into two congruent segments, so AE and EC. And then diagonal AC is also going to split BD in half. It's going to split it into two congruent segments. So in this case, BE is going to be congruent to ED. So we have BE is congruent to ED, okay, and we have AE is congruent to EC. So we know BE is going to equal ED. We know AE is going to equal EC. Can we set anything up with these equations? Yes, we can. So if we try to use 2h plus 2, we'd run into a dead end because we know what AE is, but we don't know what EC is. We know it's going to be the same as 2h plus 2. We know it's going to be equal to 2h plus 2, but we don't have a different expression to set equal to 2h plus 2 that would help us solve for h. Right, but if we look at the other set, right here, we know BE is 2h. And we know that ED is h plus 5. So this allows us to get an equation that lets us solve for h. So subtract h from both sides. So 2h minus h is h. 2h minus h is h. Okay, these cancel and we have h is 5. All it wants us to do is find the variables, but if we substitute them in, we can see what we have. So 2 times 5 is 10. Okay, 5 plus 5 is 10. Okay, so these two pieces are 10 and 10. This piece is going to be 2 times 5 is 10. 10 plus 2 is 12. So this piece is 12. If this piece is 12, this piece is also going to be 12. EC is also going to be 12. You guys were struggling a little bit with that in class. I don't know. Maybe I need a better way to explain it. I mean, that's the best I got right there, though. We'll do the other ones and see where we're at. So again, this property says that diagonals bisect each other. So number 13, we have, so again, if I were to just name it A, B, C, D, and E. Put E in the middle where they intersect. Where BD, lines BD and AC intersect. Line BD, a diagonal, bisects AC. So it's going to split AC into two congruent pieces. So AE is going to be congruent to CE. And then AC bisects BD. So BE is going to be congruent to ED. Okay, so we can have, again, AE is going to be equal to, so segment AE is going to be congruent to CE. Okay, and we have B, what was it? the worst B I think I've ever written. BE is congruent to ED, right? So we have BE is equal to ED, right? So we know this is 3D, but we don't know what ED is, so that's not going to help us solve for D. Here we have AE equals CE. AE is going to be 2D plus 1. 2D plus 1 is going to equal D plus 3. Subtract D from both sides. So D plus 1 equals 3. Subtract 1 from both sides. D is going to be equal to 2. Okay, if we substitute that in to see where we're at, okay, we have 2 times D is 4. 4 plus 1 is 5. 2 plus 3 is 5. So 5 and 5, so we're good. Then 3 times 2 is going to give us 6. So we know that one's also going to be 6. So the diagonals bisect each other. So these segments are congruent, and then these segments are congruent. Okay. I'm not going to write that all out for 14 and 15. Let's just look at it. We know right here, since our diagonals bisect each other, this diagonal is going to split this one in half. So it splits into 2 congruent segments. Here and here, these are going to be congruent. And then this diagonal splits our larger diagonal in half. So it splits into 2 congruent segments. So this is going to be congruent to this. So 4j minus 19 is going to equal 2j plus 3. Again, 2j minus 3 is just extra information. Right? We're just trying to see if you understand the concept. So we're not setting 2j plus 3 equal to 2j minus 3, right? The reason that's there is to try to make sure you understand the concept. We're setting the congruent pieces together. Okay, this diagonal bisects the major diagonal into 2 congruent pieces. So that means the lengths are going to be the same. So 4j minus 19 is going to equal 2j plus 3. If we subtract 2j on both sides, we get 2j minus 19 equals 3. We add 19 to both sides. Okay, we're going to get 2j equals 22 divided by 2. J is going to be equal to 11. So 4 times 11 is 44. 44 minus 19 is going to be 25. Okay, 25. So this piece right here is 25. And then 2 times 11 is 22. 22 plus 3 is 25. Okay, and then these ones would be 2 times 11 is 22. 22 minus 3 is 19. So we know this one is also going to be 19. Number 15. So again, this diagonal bisects the larger one. So these 2 segments are congruent. And then our larger diagonal bisects our smaller one, or minor one. So we know that these 2 segments are going to be congruent. If those segments are congruent, that means they have the same length. So the length of this one is 4r plus 4. So we know 4r plus 4 is going to be equal to the length of this one, which is 5r minus 2. Subtract 4r from both sides. 4 is going to equal r minus 2. Add 2. 6 equals r. If we substitute it in, 5 times 6 is 30. 30 minus 2 is 28. 4 times 6 is 24. 24 plus 4 is 28. So again, we know they're the same because they're 28 and 28. This one is going to be 30, so 5 times 6 is 30. If that one's 30, we know this one is also going to be 30. So that's the property that the diagonals bisect each other. So we're going to skip 16 through 21, I believe. Through 21. Yep, so cross it off, skip it. I shouldn't erase that. So our last property here is that in parallelograms, so in parallelograms, Opposite angles are congruent. So opposite angles are congruent. So opposite angles are angles that are across from each other. So angles that are across from each other. So which angles are across from 3A? It's going to be the 114. So 3A is going to equal 114. Divided by 3, A is going to be equal to 38. Right? 120 divided by 3 is 40, and there's 6 left. So 6 divided by 3 is 2, so it's going to be 40 minus 2, which is 38. Which angles are opposite each other here? 11A. Opposite 11A is going to be 110. So 11A is going to equal 110 because these angles are congruent. Opposite angles in a parallelogram are congruent. We know it's a parallelogram because it tells us it's a parallelogram. Okay. Divide by 11. A is going to be equal to 10. Okay. Last one. Again, what's opposite 40? It's going to be 3A minus 5. Right, since opposite angles are congruent, the angle measures are going to be equal, right? Since these angles right here, this angle and this angle are congruent, the angle measures are going to be equal. So the measure of this angle is 40. The measure of this angle is 3A minus 5. We add 5 to both sides. 45 equals 3A. Divide by 3. 15 is going to equal A. A is going to equal 15. 25 went over in class. We'll do it again right here because, again, this is an important question. Probably going to be on the test. Is going to be a question like this on the test. This type of wording. Okay. So I'm going to draw it. Let's think. Need more room, but I'm going to draw it up here, I think. So let's draw our parallelogram. Well, I'm going to do it down below so I have more room, and then we'll erase it. Okay. We'll draw it down here. Whole thing will be down here. So this is 25. This is going to be 25. Okay. So if we have a parallelogram, so the length of one side of a parallelogram is 3 more than twice the length of the adjacent side. The perimeter of the parallelogram is 30 centimeters. Find the lengths of the 2 adjacent sides of the parallelogram. Okay, so we know we have a perimeter of 30. So we got to find the sides and add the sides up to 30. The length of one side is 3 more than twice the length of the adjacent side. So here, we need to know what adjacent sides are. Adjacent sides just mean they're sides that are next to each other. They're adjoined, right? They're attached. They're next to. Think of it like consecutive. They're consecutive sides. One side that's right after the other. So these 2 sides. So if we had A, B, C, and D, AB is going to be adjacent to BC. Right? AB is also adjacent to AD. Okay, and then AD is adjacent to DC. DC is adjacent to CB. Okay, so adjacent just means adjoined or next to or consecutive. So it's telling us, let me erase this. It's telling us that the length of one side of a parallelogram is 3 more than twice the length of the adjacent side. So let's start with the adjacent side and call the adjacent side L. So it doesn't matter what side, we'll just pick a side and call it L or label it L. It has a length of L. The length of one side is 3 more than twice the length of the adjacent side. So we need to pick a side that's adjacent to it, so this one. Okay. And this side is going to be 3 more than twice the length of the adjacent side. So this one's 3 more than twice the length. Twice the length is 2L. This side is 3 more than twice the length of L. Okay, so we have to add 3. 3 more than twice the length of the adjacent side. So if the adjacent side is L, this side is going to be twice L, 3 more than twice L. 3 more units than twice L. Okay, so the parallelogram is 3 more than twice the length of the adjacent side. So twice L and then 3 more than that, right? So if we just had 2L, which side is bigger? This one's going to be bigger. It's going to be 3 more bigger. So we have to add 3 to this side, right? L is bigger than 2L. Side is 3 more than twice the length of the adjacent side. Okay. We want to find the length. Again, this is a parallelogram. What do we know about parallelograms and their sides? We know opposite sides are congruent. So we know this side is L and this side is 2L plus 3. So to find perimeter, you add the sides up. So 2L plus 3 plus L plus 2L plus 3 plus L is going to be 30. So 2L plus 3 plus L. All right, 2L plus 3 plus L plus 2L plus 3 plus L is going to be 30. If we combine like terms, 2L plus L plus 2L plus L gives us 6L. Right, 1, 2, 3, 4, 5, 6. And then we have plus 6 equals 30. Minus 6, subtract 6 from both sides. We're left with 6L equals 24. Okay. 6L equals 24. If we divide by 6, L is going to be 4. We substitute that back in. Okay, we would get, I'll put it on the inside. 4 and 4. 2 times 4 is 8. 8 plus 3 is 11. And then we would have 11 and 11. So 11 plus 4 plus 11 plus 4 should give us 30. 11 plus 4 is 15. 15 plus 11 is 26. 26 plus 4 is 30. So we know we have the right answer. So what's the question asked for again? Find the lengths of the 2 adjacent sides. So the lengths of the adjacent sides are going to be 4 and 11. 4 and 11. Four and 11. Um, 26. Okay, reasoning. A classmate draws a parallelogram for which one side is twice as long as the other. Okay. Classmate or the teacher. We're all teachers, right? We can all teach each other. I don't know what I'm saying. It's true, but I don't know what I'm saying nonetheless. A classmate draws a parallelogram for which one side is twice as long as the other side. One side is twice as long as the other side. So if this one's x, the other one is going to be twice as long as the other side. So we have to do 2 times x. If one side is 26 units, what are all the possible lengths of the perimeter? A classmate draws a parallelogram for which one side is 26 units. One side is twice as long as the other side. If one side is 26 units, what are the possible lengths of the perimeter? So our options, if one side is 26, so either x equals 26, so we have 2 scenarios. So scenario 1, okay, x equals 26. Right, since this is a parallelogram, we know the opposite sides are congruent, so that's going to be x and 2x. Okay, so in scenario 1, x is 26. Okay, so in scenario 1, we know These sides are going to be 26 and 26. What is twice the length of 26? 52. So we know these are going to be 52 and 52. And wants to know what's the possible length of the perimeter? Well, 26 plus 26 plus 52 plus 52 equals perimeter. So I'm going to put P equals for perimeter. So our perimeter is going to equal, what was that, 52 times 3, so 156. Scenario 2 is that 2x is the side that is 26 units. All right, one of the sides is 26. We don't know which one. So maybe the x side is 26. Maybe the 2x side is 26. If the 2x side is 26, we know x is going to be 13. So if we have our parallelogram, wonderfully shaped parallelogram there, we know these sides are going to be x, so they're going to be 13 and 13. And we know this side is going to be 26 and 26. Well, what's the perimeter of this? It's going to be 13. The perimeter, perimeter in scenario 2 is going to be 13 plus 13 plus 26 plus 26. Okay, so the perimeter in scenario 2 is going to equal, so 13 to 13 is 26. 26 times 3, so 26 and 26 is going to be 52. 52 and 26 is going to be 58, 68, and 78, which should be half of 156, and it is. So our possible lengths of the perimeter are 156 and 78. So again, just to review here, parallelogram is a quadrilateral with two pairs of parallel sides. And then beyond that, we have four properties that go with parallelogram. So we have opposite sides are going to be congruent, opposite angles are congruent, consecutive angles are supplementary, and then the diagonals bisect each other. So on the reference sheet, there's 5 properties listed. The first property is simply the definition of a parallelogram, which is that we have two pairs of opposite sides that are parallel. The other 4 are going to be the properties that follow. So the properties that follow from that definition are going to be that opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Okay. Yeah, that's it for that one.